Hey everybody, welcome back to Auto Scholar with Mr. B. I'm Mr. B. Don't forget to like this video if it taught you anything and subscribe to the channel for more automotive training. So today is our evap video, and this is going to be going into the entire evap system. And this is going to apply to just about any car out there. There are a couple of exceptions when we get into some real exotic setups out there, but for the most part, this will fit pretty much any car out there on the road. You may have some differences in parts and the way things look, but diagnosis and codes and what's relevant to each code and what to check should be the same for pretty much every car out there. So today I have this trainer here. This is a console lab trainer that we use here to teach with, and it is basically, between this board here, is an entire evap system on the board. Now, if you want to see this type of video on a car, I do have a video on GM's Pontiac G6 system where I go over every code and everything on that vehicle as well. Go in there and show you how to diagnose things and what code causes what problems. So I'm gonna put that up here and in the description so you can get to that if you want to see this on an actual car, but this is a little bit easier to teach on. I also have a Snap-on Zeus system right here. I'm just using the oscilloscope part of this just to show you the duty cycle for the purge valve. And I have our regular Snap-on multimeter here. Now, for most diagnostic problems that you have with this car, you're gonna need a basic scan tool. The oscilloscope, I don't know if you'd really call that a requirement per se, but it is nice to see so you can see the duty cycle of the purge valve. And of course, you're gonna need a meter. You don't need one like I have. If you just get you a fairly good meter, you can buy them on Amazon, you can buy them from AutoZone or wherever, and that will work just fine for this type of diagnostic work. So evap system, been around since the 70s. It's changed a lot, and pretty much the system we have now is about the same system we've had for the last 10 or 15 years. So I don't see them changing this much in the future. There are some exceptions, again, with the some of the hybrid vehicles and other vehicles out there. There are some exceptions. For the most part, this should work for your application. So I'm going to go ahead and discuss what's on this board here, show you where all the parts are, and we'll get started with the training. Okay, so for this trainer, we have this piece right here is representing the fuel tank, and we have our gas cap right here, and this would be just like a regular fuel tank in a vehicle. We also have a heating element, which is actually a light bulb, headlight bulb off of a vehicle, and that is going to make the pressure difference, and it's going to make it show up in our pressure sensor for our fuel tank pressure. Okay, so most of these fuel tanks have a pressure sensor that will relay back to the ECM exactly what pressure this system is operating at, and we'll monitor that here. 1, 2, and 3, that's your signal, and that's your ground, and that's your 5-volt reference here. Over here is our purge valve here. This would be going to the intake and goes directly to the tank, or the carbon canister, excuse me. Carbon canister's up here. We have our vent valve underneath here that is in the carbon canister. And this right here is going to be our leak simulator. So this is our small leak over here. We just turn this valve on and off, and our large leak over there, and that's measured in inches, so 0.020 and 0.040, and that will simulate a leak in this system. So what I'm going to do is I'm going to go ahead, and I've got this hooked up to a 12-volt jumper box. And let's see, let's get our meter going here. And so what I'm going to do is I'm going to go ahead and take a measurement here, and let me see if I can move this to where you guys can see it a little bit better. Let's see how that looks. Okay, so that is your measurement off of your pressure, your fuel tank pressure sensor. Okay, so as we know, pressure is affected by two major things. Okay, we have pressure is affected by volume. So the smaller the volume, if we have the same amount of substance inside something, if it gets smaller, our pressure is going to go up. We learned this in brakes class, right? But it's also affected by temperature. So if you live in an area that the temperatures will fluctuate, like this morning it was about 50 degrees where I live, and outside now it's approaching 80 degrees. So we'll see this pressure in this tank change all throughout the day during for the temperature. But we also need to tell the computer what the pressure's at so it knows when to purge and can complete its job, okay? So what I'm gonna do is I'm gonna turn this light on, and you'll see this measurement start to change, okay? Now look at the meter. Now as the pressure builds up, the meter is actually, the voltage is going down, okay? And so as the pressure gets higher and higher and higher, the voltage will go lower and lower and lower. So this sensor right here is going to be reporting back to the computer that, hey, we are building up pressure in the tank. So we can, if we put a leak in here, so if I turn this, you see I created a leak and our voltage is going back up because the tank is relieving pressure. So if this is how the computer tells if it has a leak, through this pressure switch here, and it will report back, hey, we're losing pressure somewhere, and whether it be a large leak or a small leak. So right now we're at a large leak. It's at 1.435. Let's close this back and let it go ahead and build pressure again. And as you see, that number's going up, so the pressure is building. Now, any leak can cause the pressure to go down in the tank, and that is going to cause the voltage to go up. So if we have a different leak here, this is a small leak, and so the pressure will drop in the tank much less than that large leak. And that's how we can tell the difference between like a PO442 or a PO456 and like a PO455, which is the gross leak. So because of that, we can tell the difference. The computer can tell the difference if we have a large leak or a small leak, okay? And so if we say we forget our gas cap, so now this is almost, this is atmospheric pressure. I think the spec for this is actually 1.5 for atmospheric pressure. So 1.43, we know we're almost at atmospheric pressure, and that would be that we've got, just a completely open system. Let's screw this back on. And we clicked it just like we would at the gas station, and you see that voltage is now starting to drop because we have this pressure now building up in our gas tank. And so as we drive, the heat from the exhaust maybe is close to the gas tank, anything like that, we're building up these emissions, because the higher the pressure I have, the more vapors I have in the tank, and the more vapors I have, the more times I need to go ahead and purge the system. So we store these vapors in our carbon canister because it's great at surface area. It has the activated charcoal in there, and we have more surface area, and we store all these vapors in here. And now we are going to have to purge the system. In other words, we have to get rid of all those vapors. And we do that by using a purge valve. This is our purge valve. It can be caused, a couple of different things. I know where I come from, it's called an N80 valve, purge valve, gas tank purge valve, whatever. And so you've probably heard one of these whenever the car's running and it's doing a purge. It sounds almost like a rattle noise around the intake area. And that is because it's pulse width modulated. So you don't want to just open this thing up and purge everything at once. You want to just evenly bleed all this off. So the computer is going to send a signal to the purge valve, and it is going to, you hear that pop noise. Now you see our pressure's going up, okay? So I've turned this. This is just a pulse width modulated switch. And now we're taking that pressure off the gas tank. I don't know if you can hear sounds like a rattle noise. And that is the computer is telling this valve to open and close, open and close, open and close. And that's, again, it's a duty cycle. And we can actually see this on a scope. And what I'm going to do is I'm going to put this camera closer to the oscilloscope and show you the pattern that the computer will put out on this. Okay, so I have my lab scope set up, just measuring voltage, direct current. And my probes are going to be back probed into the evap system purge valve. And so I'm going to turn up the duty cycle on the purge valve, and you'll see, you'll start hearing so this is the signal you should get from a properly working purge valve. And as we turn up the duty cycle, you'll see it just, those lines will get really, really close. And I got this set on, I think, 10 seconds or something. And then eventually it'll come just, it'll send full voltage to it. And so you'll see that will be at the very top. So you need to, if you're checking this with a meter, you're not going to get this pattern, and you're not going to understand exactly how this is working checking with the meter. Now, you can check and see if you're getting power and if it clicks, and then you can put a vacuum pump on the valve and make sure that you're getting vacuum through it and it's not broken mechanically on the inside. But if you have a purge valve problem, like a 443, a PO444, PO445, those are going to be problems with the purge valve. And this is the area you need to start looking at. Now, when we get to the end of this, I'm going to go down every code in the evap system and tell you what to check if you get that code. So you have to hang around to the end of the video for that. Also, like the video if you're learning anything, and of course, subscribe to the channel. So let me zoom back out, and I'll show you pretty much what we need to talk about as far as leak detection. Okay, guys, so let's start with the code list. Okay, the first code in your evap system, we're just going to do them numerically, and that's going to be a P0441, and that's incorrect flow detected. So incorrect flow detected can be caused by a bunch of different things. It's not a very specific code, so you really need to look hard at the whole car. Okay, so this comes from either your vent valve itself going bad, stuck mechanically, not really electronically, because we have other codes for that, but you may have more than one of these codes as well. So bent hoses that are clamped shut, large leak or something like that can also cause an incorrect purge flow. ECM not turning the purge valve on can cause an incorrect purge flow. So for PO441, it could be a bunch of different things, okay? Then we have P0442, which is going to be a small leak detected in the system somewhere. So that means that the pressure sensor is telling the computer that we have a small leak somewhere. And again, whip out your smoke machine. You want to check your vent valve, make sure it isn't hung open and it's operating properly. And you want to check your purge valve as well for any small leaks, stuff like that, on top of just smoke diagnosis and making sure your clamps and connections are straight, making sure your gasket around your fuel pump's good, all that jazz. So PO443 is going to be a purge control circuit malfunction. So that means whatever's controlling the purge valve, the computer has picked up a problem with that. So it could be it could be the purge valve, or it could be the wiring going to the purge valve, the connector, anything like that. So you definitely need to check. That's more of an electrical fault than it is a mechanical fault. Then you have purge circuit open, which is a PO44, and a PO444, and then you got a PO445, which is a purge short circuit. So that can be either the purge valve itself is shorted or unplugged, or it could be some of the wiring and stuff is touching something that it shouldn't. But basically the ECM is saying, hey, it's either completely open or completely closed, and I'm gonna go ahead and turn my check engine light on for that. So you also have a PO446, which is a vent circuit malfunction. So we have a vent valve, again, that opens and closes. This is one of the main problems with people that are putting gas in their vehicle and the gas won't go in. So the air can't come out of the tank, and that is caused by a bad vent valve or some kind of electrical circuit or circuit malfunction within that vent valve. And we have a PO447, which is vent circuit open. In other words, the vent circuit going to the vent valve, it might be unplugged, might have wiring issues, might have ECM issues. And then we have a PO448, which is that same circuit in the vent could be shorted. And sometimes those are going to be thrown together with a P0449, which is a vent valve circuit malfunction. Okay, so that's for your purge and your vent, a couple of your small leaks. We go over to the P0450, which is pressure sensor malfunction. In other words, the ECM is thinking there is something wrong with the pressure reading that it's getting, and maybe something is going on with that pressure sensor or the wiring or the signal coming off of that sensor. So definitely check all your wiring, back probe everything. You want your correct reference voltage, and do your resistance checks and everything for your ground. So P0451 is going to be pressure sensor is range or performance. Normally when we get these, it's a bad pressure sensor, but it also could be something else. It could be a leak that's causing that pressure sensor not to jive well with what the ECM is expecting. And then you have your P0452, which is pressure sensor low input, and you have your P0453, which is a high input. And then you have a P0454, which is an intermittent. The pressure sensor itself is sending an intermittent signal. So if I'm looking at those three codes, I'm going to be looking at wiring and maybe the pressure sensor itself to be causing an issue with those three codes. Okay, now getting into your leak codes, you have a P0455, okay? P0455 is going to be your large leak, okay? This is normally the code that is set when you leave your gas cap off, or it could be set by an actual anomaly with the vehicle. It's a hard word to say. But so check your gas cap. Ask the customer, which sometimes you'll get the truth, sometimes you won't. Hey, did you leave your gas cap off? Oh, yeah, I did, and I'll put it back on. And a lot of times, what I do when I get a gross leak detected is I clear the leak. I do the self-check, which is a great diagnostic tool. You can put the car into self-check mode to check the fuel proofing of the vehicle. And most scan tools, most of your basic scan tools that have some mode of bidirectional control, is going to allow you to test the system. And if the test pass and only run it twice, it's going to take a key cycle, right? If the test passed twice, then yeah, the customer probably left the gas cap off and we can ship the car. The P0456 is the tough one. That is the small leak detected. So in other words, the ECM is sensing something is very, very small leaking in the car. And those are some of the tougher repairs we have to do as technicians to find that itty bitty leak, because we're looking for something. It's not like an oil leak where it's leaving a puddle somewhere. And this is where our smoke machine is just our best friend. So, if you're really getting into this heavy evap diagnostics, I would definitely get you a good scan tool that is able to run these self checks and check and make sure that you can activate the vent valve, you can activate the purge valve. You can get out there with your meter or your scope and measure exactly what's coming to that. Okay, most of these run off a 5-volt reference voltage and ground coming off the ECM, and then they send the signal back. So most of these are going to be 3-wire sensors, and then our purge valve and our vent valves normally a 2-wire, just a power and a ground. So if I've got a vent valve or a purge valve issue, I'm going to find the wires, wiring diagrams, got to have those. Find the wires, find out what's power, what's ground. Put my meter on there, activate it with my scan tool, and if I'm getting a voltage out to there, and the voltage is, if it's a solenoid like the vent valve, if the voltage is proper, then you can kind of expect the part to be bad. But just to go out here and just be putting, I got a purge valve circuit open, I'm gonna go ahead and put a purge valve on it, guys. This is how we create comebacks. This is how we create less trust between the customer and the technician or the service department. And so with the modes that we have here in the way that I've taught you guys to look at this stuff, it really shouldn't be, you shouldn't get any comebacks from this, because you've repaired it right. But also go by and check your work. After you get done replacing any of these parts to fix any of these codes that I just talked about, run that self-check from that scan tool. Go ahead and get the car up to temperature and run that fuel proofing check, and make sure that it's passing that every time. I normally run it twice. If it runs twice and it survives on a test drive, then ship it. But if you guys are just test driving this system after you replace it, you're setting yourself up for disaster, because some of these are 2, 3, 4 times you have to drive the vehicle to get this code to set under certain conditions, okay? So if you're getting evap comebacks, definitely you want to just sit down, think about what you're doing, okay? This system is not that complicated. However, it is spread out, okay? It's all over the car. It runs all underneath it, in the fender wells, and the bumpers, all through the engine compartment. So there's a lot of places where things can go wrong. So just step back and, think about what you're doing, handle it the smart way, and double check your work. Test drives, fuel proofing. You want to do that stuff and make sure that the car is ready to go back to the customer. So that is all I have for you today on Auto Scholar with Mr. B. If you have any questions, please leave them in the comments. Now, I can't get to every question about every car out there. Hey, I got a P0447 on a Chrysler, whatever. I don't know every car out there. So it may take some time for me to get back to you. But for the most part, guys, leave me any comments, anything you have in the comments. And we'll see you next time on Auto Scholar with Mr. B.